This is an implicit differentiation problem. I have a couple spots here. This one's going to be easy to derive. This one is going to involve chain rule because I have ln of, and then this stuff inside. And within that chain rule, there's some product rule. And then this is some chain rule, but it's kind of the basics of implicit differentiation. So maybe I'll rewrite it so that now we can see the chain rule and the product rule part of it a little bit better. So I'll go through and derive each of the pieces. So this is my dx, derive it with respect to x. So I get 2x for the first piece. And then what I'll do first is do the derivative of the ln part, and then I'll worry about chain rule. So the derivative of the ln of something is 1 over that something. So I get minus 1 over the 2xy. And from there, I need to multiply by, or include my chain rule part. So I'm going to multiply that fraction by chain rule on this thing right here. So I'll do the derivative of the first. I'm going to look at the first as 2x. That's 2 times the second, y, plus the derivative of the second, which is y prime. And when I do these by y prime, I mean dy dx, so the derivative of y with respect to x. So that's the derivative of this piece. So now I need to multiply it by this guy. So I get times 2x, like that. And then I go through and I derive the rest of it. And let me put that actually in a set of parentheses. Plus, I get 6, so that's product rule on this guy. Or sorry, not product rule, power rule on this guy. And then 6y to the first power times y prime. And you can see why I don't write y to the first power, because it looks like y prime. And then the right side gives me equals 0. So at this point, I want to solve for the y prime. Notice I've got 2 spots that have y prime here and here. And this fraction here kind of is going to get in my way. So what I'm going to do is multiply every term by this piece right here, so that I no longer have this fraction here, and it'll be easier to solve for my y primes. So to do that, I get this times that, which is going to be 2x times 2xy. And then my next piece is going to be, I'm multiplying everything by this. So when I multiply this term by that, it cancels out with that. And I just get minus this thing. So I rewrote the order of the second term there a little bit. And now I'm going to multiply this guy by that guy, which is going to give me, I'll just write it as a 12. 12 times y prime, or undo y prime, so that's these 2 terms. And now these guys, so times x times y, and it's all equal to 0. So now I'm going to kind of simplify each of these little terms. What I mean by that is, like, these 2 are being multiplied, and there's clearly an x squared, and the 2 times 2 gives me 4. So I get 4x squared y, and I like to go x's first, then y's. Minus 2y, minus 2x y prime, plus I get 12. There's only one x. There's a y squared, and then a y prime, and that's equal to 0. So from here, I'm running out of space. You can see that I underlined a couple terms here. I've got in green, I have the terms that do not have y primes. And then in red, I've got my terms with y prime. So what I'm going to do is group these on the left side of an equation, and then throw these guys over to the right side of an equation. So my left side is going to be y prime times, and I like to do it this way because it helps me factor it. I want to fill in the parentheses with what would make this right here equivalent to that right there. So I'm going to get a 2x. Actually, I'm going to write the other one first, and the reason I'm going to do that is because I don't want to have that negative sign in the front here, because that makes me more likely to drop it. So I look at this guy, and the y prime is that, so I'm going to be left with this stuff. So I get 12xy squared, and then minus my 2x from this term. And then that is equal to, on the right side, I'm going to throw these guys, these green ones, over to the right side. So once again, I'm going to do the 2y first, because I'm going to add it to both sides, and that's going to be my positive term, minus the 4x squared y. And now, you may notice that there's a factor of 2 everywhere. You could go ahead and divide out by that here, but I'm going to actually wait till later to do that. So from here, I'm going to divide by the parentheses. This gives me 2y. This is the top of the fraction, and that comes from this. 2y minus 4x squared y. And it's going to be over top of this set of parentheses. So I'm going to get 12. So this is dy dx is equal to this, is equal to 12 on the bottom, x y squared minus 2x. Now, as we look at that, I look at it and I see the factor of 2 everywhere. What I mean by that is I've got a 2, I've got a 4, a 12, which is divisible by 2, and a negative 2 there. So each of those numbers is divided by 2, so you can think about it as if I multiply the top of the fraction and the bottom of the fraction both by 1/2. So it'd be 1/2 over 1/2 that I'm multiplying the entire fraction by. That gives me y minus 2x squared y all over 6xy squared minus x. And this is my final answer for dy dx. And if it was on a multiple choice question, then this is probably how it would show up. Now, just to recap, because this is the same process that we're going to go through anytime we do implicit differentiation. Given an equation first, sometimes we rewrite it to make it easier to see chain rule and product rule parts. Take the derivative with respect to x everywhere. This part right here doesn't show up often, but if it does, I kind of want to have a line, however this shows up, I want to have a line that doesn't have any fractions in it. So if I get some kind of fraction, even if it's coefficient, say I had 3/2 out front, or this was 2/3 right here instead of just 2, I'd multiply by 3 everywhere to get rid of that fraction. So anyway, so I get to this line, I rewrite that line, then I group things. I've got no y prime terms and y prime terms. The y prime terms usually are on the left side. Doesn't matter really, but I like to have them on the left side. And I factor that y prime out. I throw these guys over to the other side. Then I divide by that red set of parentheses that we can't see anymore. And then if it is simplifiable at all, we should simplify it. Say there was a y term right there that was xy instead of y, or instead of just x. I could divide by a y everywhere, because notice there's a y or more in each of those terms. But that's not there, so that's how we do it.